Hello guys, welcome to another video in the series of coding. Today we are going to do the problem which is called coins of Geekland. So in Geekland there's a grid of coins of size n into n. You have to find the maximum sum of coins in any subgrid of size k into k. And coins can also be negative. So let's try to take an example. Suppose this is a grid, right, which is of size 4 into 4. Let's say k is given 3. So in this you have to find the maximum subgrid of size 3 into 3 which is having the maximum sum. Okay, so the brute force approach to solve this problem is listing down all the 3 into 3 sized grid, right? So you can list down all the such grids and then calculate the sum. So just hover over each element, pick up that element and then calculate the sum. Okay, this is the brute force approach. It's taking a lot of time complexity. For example, for this grid itself, you will have to calculate the sum for all the elements and then you will have to do this for all the possible grids, right, in the matrix. So this is definitely the worst possible solution. That's why it's a brute force solution. Now, how to develop a better solution? See, notice something. Let's say we have a grid, right? So there are two ways to calculate its sum. What is the first way? First way is the normal way, right? Take all these elements, hover over the grid, take all the elements and then add them up and then calculate the sum. Okay, this is the first way. Now there is also one more way, right? What is the second way? See, suppose suppose you want to calculate the sum of all the elements in this matrix. So what if you knew the sum of all the elements up to here? Okay, and then just remove these three elements, so you will get the sum. This is better than calculating the sum of 9 elements. It is better to just remove 3 elements, right? Instead of calculating the sum of all the 9 elements again and again. What if somehow you had already stored the sum of, let's say this is the ending point of this matrix, right? So what if you have already stored the sum up to this portion and then just remove 3 elements, you will get the sum, right? So that is easier and that is a much more effective solution. So this is where a concept comes, which is famously also called the prefix sum concept. So we are going to use that to solve this question. Let's see an example. So what we are going to do, so at each point, at the each point, we are going to, at each cell we are going to calculate if the matrix is ending there, what is the sum of all the elements up to that point. Okay, this is what is the prefix sum logic. Now let's see it. See, for the first element, what is the sum? So I'm going to build another similar matrix here and I'm going to store the sum of all the elements up to that point. Okay, let's see using this example and then it will be clearer. So for the first case, there's only one element, so the answer is 1. In the next case, 1 plus 2 is 3, right? So we are going to take 2 elements and the sum here will be 3. In this case, 1 plus 2 is 3, 3 plus 3 is 6, right? So here the answer will be 6. Now let's take these 4 elements. 1 plus 2 is 3, 3 plus 3 is 6, 6 minus 2 is 4. So here the answer will be 4. Okay. Now let's take this element. So in this case, 1 minus 3. 1 minus 3 is equal to minus 2. So the answer will be minus 2. Now in this case, we can see that we have to take all these 4 elements. 1 plus 2 is 3, 3 minus 3 is 0, 0 plus 4 is 4. So the answer will be 4. Okay. Now let us take this cell. So it will have sum of all these elements. So 1 plus 2 is 3, 3 plus 3 is 6, 6 minus 3 is 3, 3 plus 4 is 7, 7 plus 1 is equal to 8. Okay. Now notice one thing. See, what I am doing is I was still going over all the elements and trying to calculate the sum and then getting 8, right? So there's one better way to do this. Okay, what is the better way? I want the sum up till this point, right? I want the sum of all the elements up till this point. I already know the sum of all the elements up to this point stored here. I already know the sum of all the elements up to this point stored here, right? So see, I have taken these elements 2 times. Okay, I have taken, let me mark it once again. See what I did. I took these 4 elements and I got the sum of the elements here. I took these elements 2 times and I took this element and I got the sum here. Okay, so what I can do to find the value up till here, right, to fill this value in the matrix, which is the sum of all these 6 elements, right? So what I can do is I can just look at these two values first of all. I can just look at these two values. So what is this? 4. What is this? 6. 4 plus 6 is 10, right? So the sum of these two values is 10. Now, if I just remove these two elements to, right, if I just remove these two elements and then add this element, I will get the answer. Okay, so see what I'm doing. I'm taking 4. 4 plus 6, 10. Okay, and I'm removing these two elements because I've taken them two times, right? So if I remove 3 and if I add 1, I will get the sum of all the elements here. Okay, so what will that be? That will be 4 plus 6 is 10, 10 minus 3 is 7, 7 plus 1 is 8, which is what I got by calculating the sum of all the elements. Okay, so we'll see this again and again, and then the logic will be clearer. Okay, let's see it. So now I want the sum of all elements up till this point, right? See, I want the sum of all elements up till this point. I know that the sum of all these elements is 8, okay, and I know the sum of all these elements is 4, okay. Now I have taken these elements two times, right? I have taken these elements two times. So what I'm going to do is I am going to remove these elements once, so that I just take those elements once and I add these two values also. First I will add these two values. 8 plus 4 is 12, right? So I have taken, so in 12 I have included all these elements, okay, but I have taken these elements two times. So what I will do, I will look at this value and I will remove these elements once, okay. So I will remove these elements once again, so that I take these elements only once, okay. So 8 plus 4 is 12. Now what will happen, 12 minus 6, okay, this value is 6, so 12 minus 6 is 6, and I will add this value. 6 plus 5 is 11, so I will get 11. 11 is the correct answer here, okay. So 11 is the correct answer. So this is the logic. This is very important to understand. So we'll quickly go over the entire grid and build this, and then it will be clear. Now I want the sum of all these elements up till this point. What is this? This is very simple, right? So you can just take the above value and you can add 3, okay. So what is the value? 3 minus 3 is 0. 0 plus 1 is 1. Now let us take the value of all the elements up till this point. So up till this point. So we want all these elements basically. So how are we going to calculate all these elements? So it is very simple. To calculate all these elements, what you can do is, so take the value here and take the value here. Okay. So if you take the value here, 1 plus 4 is 5, right? And then if you subtract the value here, okay, then you will be able to get the required answer. So 5 minus 2 is equal to 7, and then if you add 7 plus 1, sorry, 7 minus 1, you will get 6. So 6 is the answer here. Okay, let's calculate and see if we are getting 6 or not. See, 2 plus 4 is 6, 1 minus 1 is 0, 3 minus 3 is 0, okay. So the value is 6 here. Similarly, to find the value of all the elements up till this point, what are we going to do? We are going to take the sum here and we are going to take the sum here, and since we have taken this sum two times, we are going to subtract the sum that we are going to get here, okay. So let's not confuse. What is the simple logic? 6 plus 8 minus 4, okay. Simple logic is 6 plus 8 minus 4, because why are we doing this? Let's just look at it once. We want the sum of all the elements up till here, right? We want the sum of all these elements up till this, up all these elements. So what are we going to do? We are going to take the sum of elements up till this value. So we will include all these elements. That will be 6, okay, and then we will take the sum of all these elements. So we will include these elements, but we have included these elements two times. So we will add 6 and we will add 8, but we will subtract 4. So 6 plus 8 is 14. 14 minus 4 is what? 14 minus 4 is 10, and then we will add this value. So 10 plus 4 is again 14. So the answer will be 14, okay. Now let's just quickly fill the matrix. I hope you have understood how we are filling this matrix. So similarly, for finding the value up till this point, what we are going to do? 14 plus 11 minus 8. So 14 plus 11 is what? 25, and if you do 25 minus 8, you will get 17. So it will be 17, but you also have to take this value. So 17 minus 2 is 15, okay. Now for filling up to here, what we are going to do? So it's very simple. These elements are just what? 6 plus 1 will be just 7, okay. For filling this value, what we are going to do? 7 plus 6 is 13, 13 minus 1 is 12, and then 12 minus 3 is 9, okay. For filling this particular cell, what we are going to do? 14 plus 9 is 23, 23 minus 6 is 17, and this is 0, so it will be 17. Similarly, for filling this cell, what we are going to do? So we are going to look at the two cells here. So 17 plus 5 is what? 32, and then 32 minus 14 is what? So this will be 8, and this will be 1. So it will be 18, and then 18 plus 1 is what? 19. Now once we have these values, right, now we have to look at what is our k into k. Okay. Now this is what? This is just the prefix matrix. This is just the prefix matrix. This is not the solution. Okay. Now once we have built the prefix matrix, first part of the question is done. Now we have to solve the most important second part of the question, which is actually the question. The question is given a k into k matrix. Let's say k is 3. Find the maximum sum of a 3 into 3 size matrix in this entire matrix. How are we going to do that? Now it's very simple. Okay, now the question is very simple. So how can you find a sum of a 3 into 3 matrix? See, suppose you want to find the sum of a 3 into 3 matrix. Let's say you want to find the sum of this matrix. Now in this matrix, what does this value represent? This value represents the sum of all the elements, okay, up till this point. So in this matrix, right, 19 is the sum of all the elements in the entire grid. Okay, if you add all the elements, you get 19. So now what if you just remove the value from here? Okay, if you remove the value 4, you will be removing all these elements. Okay, so if you see, if you just from 19, if you subtract 4, you will be removing all these elements. Okay, so 19 includes the entire matrix. So from 19 subtract 4, you will remove all these elements. Also from 19 subtract 7. Okay, you will remove all these elements also, but you are removing this element 2 times, so just add this element. Okay, so add this element, which is 1. You will be able to get the sum of this 3, the total sum of this 3 into 3 matrix, and you can do it in just what complexity? In just O of 1. You need not iterate over the all the 9 elements. Instead, just in this matrix, do this simple calculation. What is 19? 19 minus 4 is what? So we'll take like this: 19 plus 1 is 20, and 20 minus 4 is 16. 16 minus 7 is 9. So this answer is 9, right? This answer is 9. So if you sum up all the elements in this matrix, you will get 9. Let's see that quickly. 4 plus 5, and then 1 and minus 1 will cancel, and then 4 plus 1 is 5, and then minus 3 minus 2 will cancel, and this is 0. So we know that the sum of all these elements is just 9, and that is what we got using our simple formula. Okay, so let's quickly see all the examples in this. Let's see all the sum of the possible 3 into 3 matrices and find out the largest possible sum. Okay, so first for this 3 by 3 matrix, so how will you do? Just look here. So we know that sum of, okay, so let's take our answer variable. So we know that the sum of all the elements up to this point is 14, and we got that from this prefix matrix, right? So it is 14. So this is, we need not subtract anything here. So right now our candidate for the answer is 14. Okay, let's see if we are able to find a better answer. So next 3 by 3 matrix is this. So how do you find out the sum of these elements? So just look at this matrix ending here. So this sum is 15. What does 15 represent? 15 represents the entire sum. Now if you just subtract these 3 elements, you will get the answer. How do you subtract the 3 elements? You know the sum of these 3 elements by looking here. So just do 15 minus 1. Again you get 14. So you know, if you remove these elements also, the sum of all these elements is also 14. Okay, so that's it. Now let's calculate the next 3 by 3 matrix. So let's see the sum of all these elements. How can we get the sum of all these elements? Just look here. This is 17. 17 represents the sum of all these elements. So if you remove these 3 elements, you will get the sum of these 9 elements. What is 17 minus 6? So 17 minus 6 is 11, and 11 is less than 14. So that's not the answer. Okay. Now let's quickly see the last possible 3 by 3 matrix. So how to find the sum of this 3 by 3 matrix? So just look at the answer here. It is 19, right? So 19 represents the sum of the entire grid. So from 19 subtract 4. If you subtract 4, you will subtract all these elements, and then subtract the value here. So if you subtract the value here, you will subtract all these elements, but you have subtracted these quantity 2 times. So just add this value. So what is this? 19 plus 1 is 20. 20 minus 11. What is 20 minus 11? So 20 minus 11 is 9. So 9 is the sum of all these elements. Now it is less than 14. So the answer is 14. So that's it. That's the simple logic. Now let's move forward to coding this. And by the way, the time complexity and space complexity is O of n square for this possible solution. Okay, so what we are going to do, first of all, we are going to convert this matrix to the prefix submatrix. So let's convert this matrix to prefix matrix, which we just discussed. So let me take for int I equal to 0, I less than I plus plus. Okay, for int j equal to 0, j less than n, j plus plus. How are we building the prefix matrix? So prefix matrix is just the matrix which represents the sum of all the elements. For example, if you take look at this value, it represents the sum of all the elements here which are ending with this cell. If you take this value, for example here, if you take 8, represents the sum of all the elements here. So how are we building this? How are we getting 8? Let us see. So what were we doing? We were taking 6 plus 4. Okay, so how are we getting 8? We were taking 6 plus 4. Okay, and we were subtracting 3. So if we take 6, we are taking all these elements, and if we take 4, we are taking all these elements, right? But we are taking this element 2 times, so we are subtracting the diagonal element. So 6 plus 4 is 10, 10 minus 3 is 7, and 7 plus 1 is 8, right? That is a simple logic. So let's quickly build this. So what you are going to do? So matrix of ij plus, what do you have to do? So first of all, add these two values, right? So you are adding 6 and you are adding 4. So the logic is very simple. Add these two values which are just adjacent to it, right? So add these two values. Okay, that's it, and then subtract the diagonal value. Matrix of ij minus is equal to matrix of I minus 1, j minus 1. Okay, and also that's it. This is a simple logic to solve this question. This will convert this entire matrix into the prefix matrix which we just discussed, so that we can calculate the sum of elements in O of one complexity itself. Okay, by just looking at the prefix matrix. Now there's one important thing. So you have to give this condition I minus 1 should be greater than 0. So whenever this is valid, this will happen. Here also let's give the condition j minus 1 should be greater than equal to 0. Otherwise this will give segmentation fault. Here also we can give this condition I minus 1 greater than equal to 0, j minus 1 greater than equal to 0, so that here it gives the proper answer. Okay. After converting into prefix matrix, what you have to do? You have to find out the sum. Okay, you have to, for example, if k is equal to 3, find out the sum of 3, all the 3 into 3 matrices. How will you do that? For example, if you have to find the sum of this 3 into 3 matrix, what are we doing? First we are taking this particular cell. Okay, so we are taking 19. From 19 we are subtracting 4, so that we will remove all these elements. Then we are subtracting 7, so that we remove all these elements. Okay, and then we are adding 1, so that because we remove this element 2 times. So this is the simple thing that we are doing. So 19 minus 4 minus 7 plus 1. So from 19 we are going to subtract 4, we are going to subtract 7, and we are going to add 1. Okay, so the simple logic is, let me quickly copy this. What are we doing? Okay. Let me take a local variable that is equal to matrix of ij. So let me just take answer. Okay, so let's give int min as the answer, and if we get a better answer, we'll change it. Okay, so for example, this is 19 here, right? This is 19. So local is 19 now. From 19 you have to subtract 4. Okay, how will you subtract 4? So local minus is equal to matrix of I minus k and j. So you go back k rows, right? For example, this is the 0, 1, 2, third row. If you have a 3 by 3 matrix, go back 3 rows, you will get the 0th row, right? And similarly go back that many columns also. So I j minus k. So what are we doing? From 19, first of all, what did we remove? First of all, we removed 4. So this is 19 minus 4. After that, what you did? 19 minus 4 minus 7. So next you removed 7 also. Now you have to add 1. Okay, you have to add 1. So how are you going to add 1? So local plus is equal to matrix of I minus k, j minus k. That's it. That's the simple logic. So this will give 19 minus 4 minus 7 plus 1. So you are adding this value, right? So you are going back k rows, and you are going back k columns also. Okay, that's it. That is simple logic. Now here also you have to give the conditions. So what are the conditions that you have to give? So I minus k should be greater than equal to 0. Here you have to give j minus k should be greater than equal to 0. Here you have to give both I minus k and j minus k should be greater than equal to 0. Why? Because it should never go out of bounds. It will give segmentation fault. That's it. Now you can give answer is equal to max of answer and local. That's it. You can return answer. So let's submit and see. So we are actually saving space if we are using the same matrix. So that's why I'm using the same matrix.